There's just a big round one. Got a massive disco workbox. Does the disco ball rotate? I tell you, it's just go and hack it and have it so if anybody tweets brain boxes, spotlight comes on. Like a mechatronic view does like TV. Hello everybody, welcome to IoT Liverpool. Welcome to Does Liverpool if you haven't been before. This is the events room. We've got co-working space the other side of this wall, and more co-working and maker space through in that side with laser cutters and 3D printers and CNC machines and all sorts of toys. So if you want to look around at all, then give me a shout after the talk, and I can give you a tour. We are a grand announcement. Kind of, it's not quite the official launch. Is it exclusive launch?
It's the Northwest launch.
The Northwest launch of a new product from Brainboxes. So Brainboxes, some of you might have seen Luke when was it you last spoke? It was a couple of years ago now, wasn't it?
Back, I think, yeah.
So yeah, Brainboxes are based just down in Speak, and I'm sure Luke will tell us more about that sort of stuff. So yeah, local IoT product manufacturing, which is cool. And they've just launched a new product, which is what Luke's going to be telling us about, and then also probably a bit about kind of what making a product is like, and how much more hair he had before he started on this process. So yeah, so that should all be good. Actually, we're not expecting a fire alarm, so if there is a fire alarm, the fire exit is out the way you came, or you can go through the other side of, like round the corner through the doors, and then far side to the fire escape. You need toilets there at the bottom of the stairs, and yeah, that's probably about it for housekeeping stuff, I think. So yeah, I shall hand over to Luke.
Thank you, Adrian. Thanks for inviting me. Hello everyone, my name is Luke Walsh. I am the MD of a company in Speak called Brainboxes. So who are we? Let's pull a slide. We make these kind of things. So these are industrial control equipment. So remote I/O, switches, Ethernet to serial, any kind of industrial monitoring kit. And we've been around since 1984, and our headquarters is here in Liverpool. And the company was started by my dad. So yeah, still in the family. So this is a slide that everyone in this room, I don't need to tell you about what it means. So for us, for the last 35 years, we've been connecting things to other things, and increasingly over the last 10 years, that data has now been moved from the device to the local network to the internet, and so that's a trend that will only continue. What I'm going to tell you about today is our new product, which we call BB400. That's how our part codes work, letter, number. So we try to find an interesting combination. And it's an edge controller powered by Pi. So for the guys here, I know you guys are technologists, and so I'm going to try and come at it from a more techie perspective than normal, and hopefully you'll find it interesting. I'm going to tell you why we did it, what can it do, how did we make it, and what the challenges were releasing the product. So this is the product. This is it here, and it's got a Raspberry Pi inside. Now the Raspberry Pi piece of this product is this compute module. So that's that bit there. So that's the brains, and then this is the electronics that we've added to it. So why did we do all that? Well, In industry, we believe there's a shift, and it's been occurring for a number of years now, and you've probably all seen it. And the shift is from proprietary technology running on PLCs, programmable logic controllers, towards open software running on PC-based platforms. Now, today, PCs can't solve all those problems, so there is definitely a place for PLCs, but increasingly, people use PC-based platforms to solve industrial problems. And so that's why we think we need this product. And the next one is, well, why would we choose a Raspberry Pi? And I'm sure most people in this audience are more than familiar with Raspberry Pi. It's the third best-selling general purpose computer of all time. I think that number's slightly fudged because there's multiple models of Raspberry Pi that's comparing it to individual models of the second and first bestseller, but it's still a very impressive number. One of the key things is there's a very, very large software-based and online community. If we tried to launch a product with a different base, then we wouldn't be able to tap into all that existing expertise in the community. And so us, a little company based in Liverpool, wouldn't have access to such a broad number of people. And there's a lot of prototyping in industry done today on a Raspberry Pi. I've been to numerous factories and seen numerous R&D labs within those factories, and everyone is doing something somewhere in those factories with Raspberry Pis. And one of their challenges is, after they've made the prototype, how do they put it into production? This platform's familiar to graduates, and it's built mostly on open source technology. So we're more than familiar with the Pi. So I guess more of a question for you guys is, why would you use Brainbox's version of this product? So our background is in reliable industrial communication products. We've been around for 35 years. We've shipped over 1 million serial ports during that time. There was a time when every M&S till had one of our products in it. Currently, every Santander bank has a number of our products in. There's lots of factories around the northwest and around the country with our products doing things. Even in the Raspberry Pi factory, they have some of our products monitoring some of their test and measurement equipment. So we've got some kind of pedigree, and we offer lifetime technical support and warranty. But here is what a customer sent me last week.
The University of Oxford has 5 global JetWatch observatories. These are telescopes distributed around the globe, separated in longitude, so there is always one thing in darkness, enabling us to collect wonderful time series data for our astrophysics research. It really isn't easy to operate an observatory from thousands of miles away on the other side of the planet. What massively helps our digital signal infrastructure are the products made by Brainboxes. We love their products. We use their Ethernet switches, and we use their Ethernet to serial converters. These are utterly rugged products. They survive extremely high temperatures, such as we have here in the Global JetWatch Observatory in rural southern India, where the temperatures get extremely hot during the day. These devices have survived really very harsh conditions, and they're utterly reliable, and they enable all the devices in our observatories to communicate cleanly and effectively with our control computers.
So obviously we were chuffed when we received that. It's a customer we've worked with for a number of years, and you can't buy that kind of publicity. And I might be slightly in love with Catherine Blundell in her voice. So what does the product do? Well, we've got this overview video that quickly shows you all the features. I don't want to bore you with video after video, but there's this is the overview. Now the hardware's changed a little bit since this video. This is the previous revision, but it shows you all the main things. So it's a small form factor, which is essential in industry because often you're trying to fit it into a space in a cabinet. It's got a detachable antenna. Often the cabinet's metal. You need to route the wireless signals out of the cabinet. We've got a whole host of industrial interfaces, so you should be able to communicate with most things on the shop floor. Not everything, because there's always another industrial protocol you've never come across that we want support. There's the Raspberry Pi inside. Now this was using the previous version of the compute module, and we did further heat performance tests and we put rubber heatsink on. We've also got an Arduino in there to control the I/O because we've offloaded that from the Pi to the Arduino. Managed to sneak a HDMI port in, and then on this side we've got the power circuitry, the UPS power supply, the wireless module, real-time clock, and an expansion bus. So that was a super quick overview of what it does. Hopefully I can get back to the presentation. Okay, so what did you see? Those are the interfaces on the device. So we've come from a place where typically we do one or two interfaces converting from one to the other, but with this device we've thrown the kitchen sink at it, and part of that is because the Raspberry Pi supports all these things really well, and part of that is because customers keep asking us for yet another combination of things we haven't come across, so hopefully we're supporting more of those combinations. So why can't industry already have Pi? Well, there are a few reasons, and the key ones are heat. It gets particularly hot in some environments. Power cycles, production equipment operators can turn machines off unexpectedly, and shop floors can have one master power switch on them to turn everything off globally and back on again, so it has to survive that. The systems are typically 12 or 24 volts, and there's often vibration. So you need a device that works reliably all the time. And the installer, the person who put this device in this cramped spot, won't be there when it fails. He'll be moved on to his next job. And it's very difficult as a software engineer to remotely debug something like this. And it's even more stressful. I don't know if you've ever been on site when the operations manager is saying, your product doesn't work. And they don't care why it doesn't work. They just know it's your fault. It's quite a stressful environment. So you need something that's robust and reliable. So with a Raspberry Pi, these are the main hardware considerations. And so how does the device address those considerations? Well, with a Pi, like I said, it has to shut down cleanly. If it doesn't shut down cleanly, you're at risk of corrupting the SD card. If you've used the Pi for any significant amount of time, I'm sure you've seen this scenario where you pull the power, you try and boot it back up again, and there's some kind of check this failure, or it doesn't boot up at all. And I've seen situations where people sellotape a spare SD card to their Pi in the field because that's a really nice, quick way of recovering. Pull out the old SD card, put in a new one. The other thing is the Raspberry Pi ideally needs 5.1 volts, which is obviously not suitable on a factory floor, which is typically 12 or 24. So what have we done about that? Well, we've got a dual redundant power supply. So that means you can plug in two separate power supplies if you wish. Each power supply can be between 5 or 30 volts, anywhere in that range. And if the power is cut from one power supply, the other one will automatically take over. So you won't have any power loss with two power supplies. What if you've only got one power supply? Well, we've also put on here a mini UPS. So the UPS, the uninterrupted power supply, are these two supercaps. So they're 25 farads each, total 50 farads. And people often ask me, well, how long does that last for? When I pull the power out of the device, how long does it stay running for? And unfortunately, the answer is it depends. It depends on heat, it depends on CPU, it depends on what you're doing with the device, but we will keep it running until it gets to a lower threshold, and then when it gets to the lower threshold, we'll tell the Pi to shut down cleanly. So depending on your workload, you might get a minute or you might get 15 seconds. It really does depend. And the other key is status LEDs. So on the front, we've shoved as many LEDs as we could, because again, when you're in the field and something's wrong, it's really helpful to have little lights to tell you what's going on. And the power management has 4 states. Pre-charge, so we quickly charge the super caps before we then switch the compute module on. Running UPS alerts when you pull the power, so you've got a period of time to finish what you're doing, and stopping is when the Pi is going for shutdown. Okay, so the next main consideration is heat. Now this is a picture of the compute module 3 with the Broadcom chip. And it typically dissipates 3 to 4 watts of heat. So what does that mean for performance? Well, what it means is if it can't dissipate the heat quickly enough, its core temperature will rise. When its core temperature hits 80 degrees, it will try and regulate its own heat. And the way it does that is by reducing its CPU. So you may ask the device for 80% CPU, but it may be too hot, so it may only really be giving you 60% CPU. And it's done that by down-regulating the processor. So obviously the core temperature depends on what the device is doing, and it depends on the ambient environment. And in very extreme situations, overheating can cause shutdown. So how have we dealt with that? Well, we've put a heat sink on It's custom, which covers the full compute module and bonds as best as we can to the lid of the chip. And what is the benefit of that other than looking like a nice radiator? This is the performance gains we see at 21 degrees C. So this is, the blue line is a normal Raspberry Pi 3 in a case, because if you're in an industrial environment, you pretty much have to be in a case. And you can see that at 21 degrees, when you ask for anything over about 45% CPU, it doesn't give you more than that, because it's overheating. And so anything above 45%, you're only getting 45% of the maximum theoretical CPU. Now, Pi, obviously, were aware of this because they released the Raspberry Pi 3 Plus just a little over a year ago. And so with the 3 Plus, they put a metal lid on the chip to help with heat dissipation. And you can see that's had a real big improvement from the Pi 3 to the Pi 3 Plus. At 21 degrees, you can run it to somewhere around 65% CPU quite happily. But it won't give you more than that. It might report it's still at 100% when it's at 100% of its downclocked frequency. And then the green line is our product, and it will, ambient room temperature, it will get to 95% CPU. So for a sustained workload, this is, if you suddenly spike up to 100 and back down again, you won't get to overheating conditions, so it's for a sustained workload. The other thing is the form factor, which we talked about in the video. It's slim, it's narrow, and it tries to add the functionality without taking up too much space. And then one of the next considerations in industry is the GPIO. So typically you want to connect to things to monitor or control them. And industrial things are typically 12 volts or 24 volts. And they may have higher current requirements. So these GPIO header pins in their native state aren't useful in that scenario. And it's very nice to be able to drive the I/O lines without overwhelming the processor. So I don't know if anyone's used Pi GPIO library, which is brilliant. You can do all kinds of fantastic things using the GPIO on here, but you suffer CPU cost in doing that. So what we've done is we've offloaded the job of the I/O to an Arduino. We've written the code with a command set for the Arduino, and that code is open, so you can modify it if you wish, and you can reprogram the Arduino. So we're not going to constrain it in that way, because I'm sure there'll be something that is useful that we haven't thought of. And also the Arduino is connected to industrial FETs, basically, so that they can sync 30 volts and almost an amp per channel. So you can connect them to reasonably powerful motors and switch them on and off directly. And there's terminal blocks and the status LEDs, so you know if you're on or off. So those were the considerations for Raspberry Pi in industry, and that's how we've tried to resolve some of those considerations. And then we've shoved it with debug LEDs. It's got multiple networks. There's 4 Ethernet networks here. There's 2 on the Wi-Fi, and there's 2 individual networks on the LAN, and we've given them default settings. So by default, this is waiting to be given an IP address from a server, and this one has a fixed IP and can control the network of its own. And there's firewalling in the software. It's really nice. And also, there's a serial port, because this is our history, and also because industrial machines, they have, the serial ports are everywhere. You can't escape them. And the serial port is configurable, and we've thought about all the things we've come across over the years. So that's the hardware. How about the software? So obviously this is where the Raspberry Pi really shines. This is why people are so attracted to the platform. The price is obviously a huge advantage, but the software support is vast. And there's a great online community. But obviously, because it's Pi, you have to do everything yourself. But I think industry needs this, because finally industry is moving in the direction of open source. And the platform is the platform of choice for industrial prototypes and industrial IoT. And the Pi community online is brilliant. There's obviously Stack Overflow, there's Raspberry Pi, but if you Google almost any Linux problem, there will be a Raspberry Pi answer. It's fascinating, because since the adoption of the Pi, that's where most people are coming from. So what software have we put on the device? We've put Raspbian Lite on there for maximum compatibility. We've got an admin interface, we've got a command line interface, we've got some open protocols, we've got Docker support, and of course we had to put Node-RED on because that's the thing to do. And I'll show you this very shortly, the admin interface. Lots of configuration. So the I/O, at the moment we support 4 protocols: REST, WebSockets, ASCII, and Unix domain sockets. So if you're doing all your processing on the device, you can just talk locally over a domain socket, which is also useful in a container. And very shortly we'll have OPC UA, MQTT, and Modbus. But if you can't wait, well, you can just put one of the standard Pi libraries on the device and it will work, of course. Docker support, like I said. And in the web browser, there's a full integrated Linux session. It's a genuine Linux session in the browser. Again, we're leveraging some open source technology to do that. And we've got some sample code, videos online. Pick your poison, whichever one you prefer, and we've probably missed something that is quite popular too. So we've got a command line interface, and the purpose of the command line interface, well, it drives the user interface, but also it means all the properties that we expose are scriptable, but also it means we save the configuration into a flat file, which means you can export the configuration and put it on multiple devices. And if you give us your configuration and say, this is how we want your device, we will ship you the product with that configuration that you choose. Key, the software updates, critical. So there's a UI for updates. We've got our own update server. It's secure, it's got a key on it to verify who it is to the device and who the device is to it. We use a standard Linux packaging system. You can configure it to be auto-updatable, but a lot of industrial environments don't like that. They say, this works, I don't want to change it, don't update it. So the choice is yours. And of course, ideally, we don't want to have to let you shouldn't have to do any writing of code if you don't need to. So very shortly, you configure the I/O and then you configure the cloud platform you're connecting to, and off your data goes. So out of the box is key. So hopefully I'm going to show you that. So I've got a device here. It's on. You see the lights are flashing. When you buy the device, by default it comes in access point mode. So you can connect from your phone or your laptop to it. And in fact, I'm connected to it now. So if well, that's interesting. You can't actually see my Wi-Fi because the screen is too small, but it is connected to the Wi-Fi of that device, and I can show you that by quickly going. Yeah. Okay. So you can see I'm connected to the Wi-Fi network of this device, and we're actually by default we forward the internet connection through the wired port to the Wi-Fi, which is handy for a scenario like this for the presentation. So all you need to know about the device before you start using it is its MAC address, and the last 4 letters of the MAC address are what the access point is, and it's also what the host name of the device is. So I can now log into this device by typing in the host name. Because I'm on a Mac, it's silly, you've got to put .local at the end, but if you're in Windows or Linux, you don't need that. And of course, the first question a lot of people say is, it says it's not secure, what does that mean? Well, this is a problem with all IoT devices. Browsers only trust security certificates which are in the root cache, and security certificates can only sign for domain names which are global and not local. So you can't have a scenario where it will say tick out of the box, unfortunately, but I think that's a very sensible precaution on the part of the browser, and it's just something we have to work around that we've got in the quick start guide. So it is secure, you do get a secure connection, it's just not trusted. So by default the username is BB, and by default the password is again those last 4 digits, so we recommend you change these as soon as you log in. The last 4 digits of the host name is 0008, and once I've logged in, Here I can see the, no, I don't want to save that password. All the flashing lights which are on the front of the device you see on the web page, and it should all stay nicely in sync. And the first light that comes on for the first time is that one, the A light. And this is the admin light, so you know you're logged into this one here because its lights just come on. So it's a small measure of security. The next step is, if you've got a number of these devices, how can you be certain? You might have a few logged in. How can you be certain it's that one? We've got a little locate button, and when you click on that, you get little flashing lights. Great. So I know I'm connected to that one right there. So I'm here. I can see something's working. Great. The next step is I'll make my way down the menu. This is the I/O configuration page, which I have not reset, which I should have reset. Let me just. Okay, I've already configured my I/O, and I did do my practice presentation. It's foolish. So I've configured my I/O to present 4 inputs, and I've labelled them, and you can see what the LEDs are showing, and they match the LEDs on the case. But you can configure your I/O however you like. You can say that this is not an input anymore, it's a motor, and it's an output. So if I save that configuration, you'll see that that changes. And because it's an output, I can control it. We don't make them clickable out of the box because you might be connected to something important and you might not want to click it by mistake. Now I can switch my motor on and off, and the corresponding light for those on the front row is going on and off. So that's the configuration of the I/O, nice and simple. That's interesting. And then, of course, you want to configure the protocols, and again, it's all nice and simple. By default, they're all on, and they've got various default ports, and and we've got links to FAQs. Okay, you want to use this protocol, the REST API. Click the FAQ, and you'll see how to use the REST API. You want to use the Unix domain socket. There's the FAQ. Of course, the Wi-Fi is configurable, and you can see that there's my access point defaults. But I could switch on my other radios if I wished. Now, the hardware supports dual radio mode, but currently we're only supporting one of those radios at a time. So you can choose which of these radios to be on and off, and if you switch them on, you get various configuration that comes with it. Obviously, there's a Bluetooth screen for the Bluetooth radio, and then apps, and that opens Node-RED. But before we go to the Node-RED, there's a lot more on the configuration because we are using some good software. You can see all the logs, you can see the state of your device storage, you can see the state of the network, and as you can see, I've connected to lots of things here. There's the Docker network, there's the wired network, there's the Wi-Fi network. There's my running containers, and as you can see, Node-RED is running, and also we've put Watchtower on there, and so that will automatically update this container. So if we make improvements to our Node-RED container, you will get them automatically. And then we've got services and accounts and software updates. So this will query any of the repositories that you've got hooked up to the system and download those updates for you. And then finally, the next thing you might want to do is start playing around with an app, and you can go to Node-RED, which is pre-installed. A bit tricky to use on this side of the screen, but you can see, if I move this over, we've got an example for WebSockets, we've got an example for REST, we've got an example for Modbus. So in this setup here, the BB400 is talking to its own network, and this device is on its own network, so in effect it's firewalled off from the rest of the network, but it can talk Modbus to this device. And if I just quickly enable one of these, well, that is enabled now, useful. I don't need to redeploy. I don't know how to do it when the screen's small. Adrian, how did you go to the UI bit? There was a button there.
What for the Node-RED?
Yeah, UI?
Yeah, I think
Sure.
just you.
Okay. Okay, you can start playing around with the inputs and the outputs and controlling them, which actually, partially seems to be working on the demo. So there's the be out of the box with the device. And hopefully that means very quickly you can get up and running. So you buy the device, you're in the box, you just need to plug the power supply in and you can connect to it from your laptop or your phone and then configure what you're doing with the device. Okay. Let's go back. So out of the box is key. Now, because of the audience today, I thought you might find it interesting how we made it. I'm sure a lot of people in the audience make hardware and software combinations for their customers, and we have all the same troubles as I'm sure you have too. So first revision, this prototype, we did a lot of testing of this power supply circuitry. We went to all kinds of vendors to figure out the right combination of characteristics. You can see here's our Ethernet and USB ensemble. There's our original Wi-Fi module, and there's the compute module 3. So from this, we probably had this for 6 months while the hardware team figured out if they were happy with the combination. We went to a production prototype, which is Rev 2. But this was a high-risk design for us because there are so many pieces to it. There's lots that could go wrong. I'll give you some ideas of what wasn't right. So ground and power, originally we were routing them through the flexi connector, and if you've got 24 volts and almost an amp on one of the I/O, then the ground return path is going through the flexi connector. That was a poor design decision. So we switched that, and so we've got a separate set of pins for the power, and they can support plenty of current. And very, very recently, Raspberry Pi introduced a new compute module. And we thought, great, they've addressed one of the key issues, this is brilliant, but we're releasing very shortly. And we've already designed the heatsink. So we have to redesign the heatsink, and one of our suppliers was really excellent at doing that, but that was a challenge. And of course, once we redesigned it, we forgot that the harness set didn't quite work with the redesigned heatsink. The radio module, this was our original radio module. We had a number of software issues with it, and in addition to that, there were some hardware issues. So the hardware issue is we've got this UFL flexi connector, and it's screwed onto the front of the case here. So for the operators in production, this is a pig, to be honest. They've got to manually plug on all those UFLs, and then screw on all the hex nuts and make sure it's not twisted and it's on properly. So we switched that out in the new design, and we've got a through-hole mounted antenna, and we've got a different radio module. But this new radio module has made the design really complex. So around here we've got all kinds of 0402s, so those are parts that are 1 millimetre long and 0.5 millimetre wide, and making sure they're all placed correctly is a real challenge. So the product overall has 514 components, and there are about 7,000 solder joints. So just in the production process, there's plenty of opportunity for failure. So here's our production process. I tried to put it on a slide. It doesn't look very pretty. So we've got loading equipment, solder paste with inspection, pick and place machines, buffers with inspection, and an oven. And then we have operator workstation where they put parts that can't be fitted by hand, by the machines, selective solder, AOIs, that's automatic optical inspection, which is something we're trialling for the new product. And then we've got various functional and electrical tests and final audit. So at this point, again, because of the audience, I just scoot out of here. Here is a very quick, I'll put this on double speed. So here's the product. This is not the product, this is a different one of our products going down the production line into the solder paste machine. This is a squeegee system that pushes solder paste through a metal stencil onto all the gold parts of the product. So now the product has the solder on it, now it goes into the pick and place machine. Obviously this is 2 times speed sped up, but it still runs pretty quick, this machine. Every time it goes backwards and forwards, it's picking and placing 10 different parts. We've got our own production monitoring system. So you can see each time it's going back into the middle, it's picking and placing 10 parts, and some of the size of the components is really minute. It's a very impressive thing. So that's the pick and place, and on this particular product it took a bit longer than I thought, the video, so maybe I should have been at ×5 speed at this point. But then we go on to the next process, so it goes through that, and this is another pick and place machine. This is much older than the first one, and so we give it the easier jobs. because it's like me, it's got bad knees. And so it's placing things like USB connectors and anything large that the vision system finds easy to place, and the tolerance isn't such a big deal. Then it goes into a turn unit, so through some conveyor, through a 90-degree turn, and at this point I'll stand out of the way and John, our machine operator, John, will start inspecting it visually, and this product needs some extra solder on the top so that some of the legs are really robustly held in place. So John is manually inspecting while he's solder pasting, that's the first part of the line, and then he's updating the system to tell it that those 8 are correct. It goes through the oven, and then when it comes out the other side of the oven, there's John again, he's putting the through-hole parts on. So these are the parts that machines can't place, and actually you get better rigidity and strength from them if they're through-hole. So typically connectors will use through-hole. So John then puts that into the next machine. So this machine is a selective solder, and what this does is it has a fluxing station and a soldering station. And just where we program it to, it will flux and solder the underside of the board. So any legs that are sticking through the board, it will ensure that solder joints on those legs are correctly soldered. And if you look carefully, the PCB is coming from one machine to the next. That's the vision system, the solder station, and then the solder part is coming into place to solder the underside of the board. We've got this new AOI system that this operator's Luke is really struggling to use, and this is the final product. So this particular production run, we're making these USB to serial adapters. So, yeah, I hope that was interesting. And then of course the final thing is software always takes longer than you think. The hardware often follows a structured plan. The hardware engineers say they think better than the software engineers. I'm not sure, but the software always takes longer. So some case studies. So I'm going to finish with one case study. So this is a case study from RS Components. And if I click here, great. And if I...
Brainbox's mission is to enable the fourth industrial revolution for our customers, no matter what their size. Our products are used in all kinds of industrial settings, in factories, on production lines, subsea, in the power industry, in oil and gas. So Brainboxes creates hardware and software to allow customers to monitor machines, to pull data. And it's a standard problem for people in factories and in automation. You should be answering questions based on real data, not on anecdotal evidence. Maintenance is essential to ensure your machines keep running. But the flip side of maintenance is it costs you money to maintain your machines. So you're constantly trading off these two things, ensuring the machine continues to work every day versus stopping the production line. So it's not the cost of the machine necessarily, it's the cost of not running the machine. We can now maintain lots of things that previously it would not have been economical to monitor. If we consider that we want to move from preventative maintenance to predictive maintenance, we need a model of the machine's health. And then you can associate the cost with the current running of the machine versus the cost of the maintenance. RS is one of our key partners. We've been a supplier to RS for over 20 years. What's really nice in the last few years is RS use our technology within their own facility and understand the benefit of what it is we're selling.
So we have up here 20 cranes which are half a mile away from here. So Brainboxes have introduced an IoT system which you can connect to any information connected to your system, and we can see it in a format that's usable. So as well as putting one of these screens in the crane so the guys can see how their performance of the day has been, we will copy this into the supervisor and the manager's office so that at all times we have good visibility of the crane information.
You can start to do trend analysis when you get data over a longer period of time. So all of these different areas and trends give you insight in where you need to target your maintenance strategy to get better longevity and health out of your equipment.
This is Brainbox's production line. There's various processes involved in the manufacturing of PCBs. And here again we've got some monitoring. Okay, that's enough for me. Yeah, the key there was it was really nice that RS were using our products as well in their warehouse, and that's the second project they've done with the products. So there are a number of other case studies I can show you, but I think my time's pretty much come to an end. I hope you guys found that interesting. I hope maybe you'll see how you could use that, or maybe use some of the information. I'm really happy to chat to you afterwards. Thanks very much. Cheers.
Thanks very much for that, Luke. My pleasure. Time for any questions?
Yeah, happy to. Yeah.
Got any questions?
I have a question.
Oh yeah.
So I've used pies in industry,
Okay.
and like I was part of a user group where we were trying to use them more often for interesting things. But we never really needed any intense processing power. I was just wondering where that requirement came from.
That's a very good question, David. The heat characteristics that show you the maximum processing power that you can achieve given what you ask for become more and more important as the ambient heat gets hotter. So yes, you're right in saying how many intensive processing applications may be running on this device, because you may just be doing a small amount of analysis of data before sending it on somewhere else, for example. But that CPU envelope becomes smaller at hotter temperatures, so if you're deploying them in hot environments, you won't get even 20-30% CPU out of the device, so then it becomes super important having the heat dissipation. But yeah, you're right. I'm yet to come across a really good application which is running at 100% for 10 hours.
And I guess my use case was kind of biased along, so we were just doing things that PLCs were generally doing, but were taking up too much room and being a bit pointless.
Right.
So we weren't doing very much with the data.
Yeah.
We were just driving outputs and things.
Right.
So not really an interesting use case for it.
No, but it's not atypical, is it? There's a lot of situations where just doing something simply and reliably is pretty important. Yes, sir.
Can you talk a bit about security, because that must be a massive issue for you if you get routed and you've got a network of these things within the factory.
Yeah.
Problem. How do you approach it?
Of course, security is a huge issue. So the software updates are a key part of that. By default, we have these different I/O protocols open. But once you've decided on your configuration, you should close all the unnecessary ports, right? And the connection to the device is over TLS 1.2, and when that changes, it will upgrade. So you can't cover every security angle. You certainly can't cover physical security unless you put glue in your unused ports. But in terms of software security, we've covered all the bases, we feel, but there's always another angle of exploitation for sure. It's critical. So it's more than just a device on the manufacturing network. You need to think about the network as a whole and how you're separating your manufacturing network from maybe your office network and from the outside world.
And does that happen? Because a lot of things seem to be quite open out of the box. I mean, just thinking about the exploitation of the ammonia centrifuges, for example, while putting the work, you start to get concerned about these by default. If you don't change default settings, if you don't, I'm just wondering about the lockdown ability of them.
Sure. I mean, the configuration file that we're using by default has most things on and open, right? So we have considered having a second file that the user can apply, like the deployment file, where everything's off by default and you have to choose which one you're explicitly turning back on, which is another step in the right direction, but it's by no means the complete answer. Yeah.
So the software,
Yeah.
you run on it, so it's quite reduced power and RAM and everything. What do you use for database? What do you use to drive the web interface?
Yeah, so the web interface actually only comes on when you connect to the port. So it's not running in the background at all unless you choose to talk to port 9090. So if you don't need it, it's off. It's completely off. The data store we're using for the settings is just a YAML file and a JSON file as well. So we're not talking to a database on the device because we wanted to leave as much of it empty for someone to do what they wanted with it as possible. And Node-RED is actually running as a container, so that default application that you saw Node-RED, you can delete the container and that will free up 600 megabytes straight away. It's gone, and then you can put something else in its place. So we tried to keep the footprint as light as possible. The software guys, when they've been writing all these layers of software, have been analysing the performance as much as possible to try and keep it under various limits. But yeah, it's tricky to get that right, for sure.
What sort of safety accreditations you have to go to? Because obviously it's an electronic device,
So that again is, so we do this a lot with our devices. So there's all kinds of EMC testing. So my best recommendation is there's two guys I recommend who work for test houses that you talk to. So let's say you have a specific product you're trying to approve. I would get the opinion of these two particular guys because they will give it to you freely and they won't be trying to just pile on things that are unnecessary but make them money. And it's a really good way to help weed out what you really need by law versus what the test house is trying to sell you as an additional thing. So we spent a lot of time with this device talking to all the test houses, figuring out what we needed, and then basically pulling out everything that was unnecessary because they will layer on all kinds of additional things that look official and important but actually are not required. There's lots of places to look there. So from a safety perspective in America, you need to be looking at UL. In Europe, it's a part of CE, or you could look at VDE instead, but their approval process is more expensive, and typically people will accept UL if you've got either or, they're happy with one or the other, VDE, UL. And then obviously this has radio equipment on it, so for CE, there's the CE radio equipment directive that you've also got to comply with. So we've got in-house test equipment that will give us the pre-approval testing, so we're confident then before we go and spend all the money with the test house. That's really helpful. And another really good contact was at the University of John Moores, and they have an anechoic chamber and various test equipment. So as well as doing our own testing in our building, we could take it there to verify some things as well before we then pay the money for the test house. So we talk to test houses and talk to more than one because it's a minefield to be.
And is that an expensive process as well?
It can be extremely expensive if you're not careful. If you take their initial quote at face value, it can be very expensive. Yes. So the radio module on this, we use the pre-approved module, but even though the module's pre-approved, you still have to test it, but you just test it to a lesser degree, and that was like a cost choice as we were going down that path. Yes?
What's that?
What is that? This needs a bit of an update, to be honest. This is our old school demo of the Internet of Things, and it's like a typical industrial setup. This is like a machine. The machine's got some inputs and some outputs, and we're monitoring the machine. And in one version of this demo, we've got a PLC and a HMI, and we're basically demonstrating interoperability between the PLC and the HMI and this modern web technology, which to you guys is not modern at all. It's just what you do. So we've got some web sockets talking to here on this side, but then we also have this talking modbus to that, and then this talking to a PLC and a HMI. And so we're basically demonstrating how you can get from a machine without that technology and retrofit to add technology to it. So this particular demo is on a web page. So this laptop's on a different network to that. But if I get my link up correctly, there's the web page. Maybe some of you have used Dataplicity. It's a great piece of software. It allows tunneling through the internet. There's plenty of options out there. And so we can see what's going on the demo of the internet. So obviously this doesn't have to be in the same room or the same place. and I can control my machine over the internet, and I can sound the alarm, or I can see the performance of the machine over time. So that's kind of a very simple retrofit demo of how you connect this thing to buttons and sensors and actuators on a piece of industrial kit.
Got a question.
Yeah.
Going back to the case of security. So say an update becomes available to the operating system.
Yeah.
If you want to say a critical security patch which needs to be applied, how is that pushed out to all the different devices?
Yeah, sure. So it's ultimately it's Linux, right? And Debian and Raspbian use the apt packaging system, and so that is on the device. And the apps packaging system presents itself in this software update tab. So if I check for updates now, basically it's querying all the app repositories, including the BrainBoxes repository. So we've got some of our software there, and all the critical stuff will be in the main Raspbian repository. So you can choose how you apply these updates, right? So there are apps packages which you can use to control your update strategy. And you could also put it on a cron task. So we're not telling you the way to do that, we're giving you a few options on what's appropriate.
So you're providing the updates and letting the consumers see how they want to actually...
Yeah, 'cause, I mean, one of the challenges is people don't want change in some environments, so you can't force it on them. So although you could say how great it is to have security updates, some people do not want them because it could affect some other part of their system, and they're not willing to make that compromise. So, yeah. Great. Oh, yes.
Yeah, one question. How do you generally find the reliability of the Pi modules in terms of, putting them into this sort of environment? Obviously you're doing things to help.
Yeah.
Yeah.
Well, yeah, so I mean, the first thing to say is we're not using the full Pi, we're using the compute module. So that's got a lot less parts on it. So there's a lot less opportunity for failure from what they're providing. What they're providing is very good. And so before we had this product, we had a number of Pis in industrial environments doing things. And it became apparent to us that we needed something more reliable. And the key failure we see is the power supply. So pulling the power is the key primary source of failure. So if you can deal with that like we have with the UPS power supply, that will get you a long way towards a much more reliable product. That's typically due to the SD card.
Cool. Well, sorry.
Oh, sorry, just one more quick one. It's a massive undertaking to get like a product from concept to reality, especially when you've got to consider CE mark and stuff. And like how complex and how many features this thing has, hardware and software as well. Like how many people how much of it did you do in house, and like how long did it actually take you?
Well, we've got hardware and software engineers. My hardware engineer told me at the start of the project, this is really complicated, and he wasn't kidding. And I think I naively went into it thinking, oh yeah, it's fine, it's just a Pi. But it was a huge undertaking, and that's why I can't say it's available today, because it's still not quite ready, and that's why the due date is a few weeks away. But we've got 5 full-time software people working on it, and we've got a full-time senior hardware engineer still working on it, and we still need to make our other products and design things, so it's a challenge to juggle all that, for sure.
You're still an SME, right?
Yeah.
I can't imagine many SMEs would take on like a project as complex as that in a short space of time.
Yeah, it's a gamble, isn't it, for any SME you've got to take a punt and make an educated guess on where the market's heading, right? But as an SME, you cannot be on the bleeding edge, because any guess you make is going to cost you loads if you're wrong, and the downside's huge. And so you've got to step away from the bleeding edge and say, okay, how close to the forefront of technology do we want to be? And what are we seeing the market doing, and therefore, where do we think the market's going to be in a few years' time? So for us, we had all those discussions, and we thought this was the direction that the market's heading in. It may be, I mean, from an electrical perspective, it's the most complicated product we ever did. from a software perspective, it's not. 15 years ago, we were the first company in the world to have 5 fully qualified Bluetooth devices, and to have a software team to write a Bluetooth stack was a huge undertaking, and so we learned a lot of lessons from that. We may be relearning them again, to be honest. It's tough, it is hard.
So just to follow on from that, how long has this process been from conception to...
Probably 2 years.
2 years.
Yeah. And obviously I thought it would take half that time or a third of that time.
That is quick though. That 2 years is really quick.
Yeah.
All of this.
Yeah, I mean, we've got a really good team of guys. We are looking for another senior software engineer, so if anyone in the room knows anyone, I'd love to meet them. So yeah, that's us. Oh, and one final thing to add. This is our out-of-the-box application section. Clearly there is one application there. If you think you've got an out-of-the-box application that could go on this device, that we could ship with everyone we sell, and which a user could have access to a free version of it, and then it's up to you how you monetize that thereafter. We'd be very interested to talk to you as well. So yeah, please be in touch. Right.
Cool. Well, thank you very much for that, Luke.
Pleasure.
Looks great.
Yeah.
And,
Something like a decent.
and the software and stuff is all, very much. Very good. Our next, in a complete break from any norm that I've set over the past how many years Liverpool's running, we actually know who the next speaker is going to be and when the next. Obviously, we haven't actually got the meeting announcement now yet, because that would be just, you'd all just wouldn't have turned up. So you'd be like, this isn't IoT Liverpool anymore. But Marty is going to be talking on International IoT Day, which is the 9th of April. So there's a relatively short gap for the next one. And you're going to be talking about the robot operating system is what? Yeah. Ross? Yes. Yeah.
So it's not directly IoT, but
Sounds interesting.
it has a way.
So yes, that'll be good. So there will be a Meetup announcement going out really soon, honest. Yeah, probably not tomorrow because Gadget Show are going to be getting filming stuff. Apparently, maybe the 3rd of May that we might be on the show or something. So they said. So tomorrow's going to be a bit busy, I think. But yeah, 9th of May, 9th of April even. Will be the next IoT Meetup. There'll be an announcement out of the Meetup group soon. So yeah, thank you all for coming. I shall see you soon. There are still some more beers probably, so feel free to hang around, chat a bit more. And if anybody wants to look around the rest of Does Liverpool, see the toys and the workshop and things, then give me a shout and we can do a quick tour. Thanks a lot.
Yeah,
Thanks.